Number 16 tells us to use logarithmic differentiation to find the derivative of that function. And so what's hinting at here is that we don't really have a formula for this. X raised to the 2x. We've got a variable base and a variable power. We don't have a formula for that. We have a formula for x to the n, that meaning top's constant, and we have a formula for the constant base, but not when we have both the base and the exponent varying. But the process we can use is logarithmic differentiation. And so let's do that. And so what that requires is, because I've got this exponent combination here that I don't have a formula for, what I'll do is take natural log of both sides. And that allows me to get rid of that exponent in some sense. So this becomes natural log y. This side, I can bring the exponent out in front. That's one of our properties of logarithms. And now I can take the derivative of both sides with respect to x. So here it is, derivative of both sides with respect to x. And on this side, these variables don't match up, and so we know we have to use the chain rule. The chain rule says take the derivative with respect to what you see in the normal way. We'll derivative natural log with respect to take the derivative of what you see with respect to the variable that you see. And that's the derivative of natural log of y, which is going to be 1 over y, and then you multiply by the derivative of the inside function, which in this case is y, so you get y prime. And then this side is a product rule, and these are all x's, so I can just use my normal product rules. The derivative of the first times the second plus the derivative of the second times the first. And so over here I'm just going to write this as y prime over y. Derivative of 2x is 2 times natural log of x. Derivative of natural log of x is 1 over x times 2x. And so what I get is y prime is going to be 2 natural log of x plus, well, here I'm going to have 2x over x, so that's going to cancel, just leaving with the 2. And the y prime, the reason I wrote it as y prime is because I'm going to multiply through by y, and so there'll be a y there. And so this says your answer must be in terms of x, but you don't need to simplify it. In other words, don't leave the y sitting here. Just turn it back into what it is. So y prime is going to be 2 natural log of x plus 2 times x to the 2x. That's what y is. And so that would be your derivative of that function. So not a formula, but there is a process that allows us to handle it when we do have a varying base and a varying exponent. And then the last one here on this page, chain rule, because I've got something on the outside, something on the inside, so I'll just start on the outside. Take the derivative of the outside function. Well, derivative sign is cosine. Blank. You fill in the blank with the inside function, and then you have to multiply by the derivative of that inside function. And then you go through again. So I still have this cosine square root x squared plus 1. This one, my outside function this time is square root. Still has an outside and inside function, and the outside is square root. So I start on the outside. Derivative of square root is 1 over, that's a times, 1 over, I don't like the looks of that times bothering me, times, derivative of square root is 1 over 2 square root blank. You fill in the blank with x squared plus 1, and then you multiply by the derivative of that inside function, x squared plus 1. So now I have cosine square root x squared plus 1. I still have this 1 over 2 square root x squared plus 1. And the derivative of x squared plus 1 is 2x plus 0, so I just get a 2x there. And it says simplify. There's really not a lot to simplify. You cancel out the 2. And you can write this as a single fraction. Both of these will go in the numerator, so I'm going to have this x, and I'll put it first with this cosine. That's in the numerator, and then all I'll have in the denominator is square root of x squared plus 1, and just resist urges of canceling things, because this cosine's, this square root's inside the cosine, you can't get it out of there. So don't try to take the square root, because you can't. This is not a perfect square under here. Anyway, so just leave it like that.